All right, so for this problem here, this is one of those tougher mass percent weight problems because it actually involves a step before you could get to the weight percent. And I thought this was a good one to go over. This was the first problem off the homework worksheet that you guys did a few days ago. Oh, and it looks like my computer is lagging again. Yeah, so you guys will see kind of a lag in this video too, sorry. We have a mixture here, and the mixture that we're looking at involves copper sulfate, and there's also a copper sulfate pentahydrate here. So you guys have a mixture of two things that are inside. So just plain copper sulfate and then your copper sulfate pentahydrate. And you're told that the entire mass of both things is 1.25 grams. And then you take this mixture, we heat it at a hot heat, we evaporate out all the water, and then you're left with only 0.832 grams. And you're being asked to calculate out what the weight percent of just the copper sulfate pentahydrate is inside the mixture, okay? This looks pretty simple, and it would have been simple, but you're dealing with the mixture with copper sulfate as well. So you can't just take your subtract out the mass of the water and then just do it out that way. You do have to take a look at this as a stoichiometry problem, but because you know what happens to the hydrate when you heat it, it's actually not that difficult to do. So we're just going to look at the reaction of copper sulfate pentahydrate and it breaking down when you heat out all the water. So the copper sulfate is going to come out, and the 5 water molecules are going to be broken down like this, and the 5 water molecules are what gets evaporated. Okay, so you know by looking at the total mass of 1.245 grams, and then if you subtract out the mass that's left over after you heat everything, you end up getting 0.413 grams of water that had been evaporated out. Okay, so with this, you guys can now begin your stoichiometry problem. The 0.413 grams of water becomes your A here, and your B, I'm trying to figure out the weight percent of the hydrate, so the copper sulfate pentahydrate would become your B. Now, I know some of you guys are thinking, well, what's the point of subtracting and getting the grams of water? Why can't we just take the 0.832 and then use that as my copper sulfate for A? And the reason why you cannot do that, again, is the fact that this is a mixture, and the 0.832 grams that are left over, it is from this copper sulfate right here after you heat it up. But some of it also is from the original copper sulfate that was in the mixture as well. So that's why you can't just use that 0.832 and then use my copper sulfate as my A. That's why we are beginning with water here. So this one's kind of a tricky problem in that. But we're going to take my 0.413 grams of water, and we're just doing a stoichiometry setup here. I need grams of water on the bottom over 1 mole of water on top. And the molar mass of water is 18.02. Okay, and I want to get rid of moles of water, so I put moles of H2O on the bottom, and I want to convert this to moles of copper sulfate pentahydrate, and I have 5 moles of water from my equation, and I have 1 mole of copper sulfate pentahydrate. And lastly, you're going to take this all the way out to grams. So in 1 mole of copper sulfate pentahydrate, if you looked up the molar mass for it on the periodic table, it would add up to 249.72 grams. Okay, so if you multiply all of this and then you divide, you would wind up with 1.145 grams of this copper sulfate pentahydrate. Okay, now I skip this over a little bit. Now from here, you're not done because you're trying to solve for the weight percent of the copper sulfate pentahydrate in the mixture. So if I know that this is the amount that I have of the hydrate, and then I know that the total mass was 1.245 grams, to get your weight percent is the exact same thing as your mass percent, which is what we called it in the notes. Okay. All you're going to do is divide. So it's 1.145 grams over the entire mass of the thing, and you times it by 100. And with three significant figures here, and I'm only going to use three because I started off with 0.413 or 0.832 grams, and we end up with 91.9% of the mixture being made up of the copper sulfate pentahydrate. That means that the rest of it, the 8.1% of the mixture, comes from just CuSO4, just the copper 2 sulfate. Okay, and that is it.